Hi, I'm Thomas. Welcome back. Our topic is integration. In this lesson, we'll learn how to integrate using partial fractions. Our requirement reads, use partial fractions to find the integral of 8x squared minus 19x plus 1 over quantity 2x plus 1 times quantity x minus 2 to the power of 2 with respect to x. Going to our algorithm, step 1, identify function type. This is a rational function, meaning that in our expression we see one function divided by another function. And when we're dealing with a rational function, unless it's a simple rational and we see an opportunity to use substitution, we'll likely want to use the method of partial fractions. Before beginning the process of partial fraction decomposition, I need to be sure that I'm dealing with a proper fraction, which means that the degree of the numerator is less than the degree of the denominator. So looking at the numerator, I see that the highest degree of the variable is x squared. And in the denominator, I see in the first term there's a 2x, and in the second term there is an x that would end up being squared. So notice that this results in x to the power of 2 over x to the power of 3. And as the degree of the numerator is less than the degree of the denominator, we're ready to go. Working on our partial fractions process. In the algebra section of the course, I go into the step-by-step procedure for applying partial fractions. In this case, I'm simply going to work through that process, not necessarily show every single calculation. If you want more practice with partial fractions, then refer back to the algebra section of the course. Let's start with our integrand. 8x squared minus 19x plus 1 over 2x plus 1 as a quantity times quantity x minus 2 to the power of 2. We will set this expression as an identity with, and now I'll set up my partial fractions. The first term is linear, 2x plus 1, so I want one fraction, a over 2x plus 1. Second term is quadratic, so we will use two fractions. First, that term as a linear, b over x minus 2, and then as a quadratic, c over quantity x minus 2 squared. Now we'll multiply all terms by the denominator of the expression on the left side of the identity. On the left side, we will have 8x squared minus 19x plus 1 is an identity with. The a term, when we multiply the a fraction by the denominator on the left side of the identity, we're left with a times x minus 2 squared. Notice that the 2x plus 1 term is already in the denominator of the a fraction, so when we multiply by that term goes away. The x minus 2 to the power of 2 ends up as a multiplier for a. Similarly with b and c. b times 2x plus 1 times x minus 2 as a linear. The denominator of b is x minus 2 as a linear, so one x minus 2 is covered. We need the other x minus 2 along with 2x plus 1. Plus c times 2x plus 1, the term in the left denominator, which is not in the denominator of the c fraction. From here, I'm going to shortcut the process. I'll tell you which x's I select as inputs and which parameters those x's enable me to calculate. If we let x equal 2, then c equals negative 1. If we let x equal 1/2, then a equals 2. And if we let x equal 0, then b equals 3. Now I'm going to rewrite my integral using the addition of the three fractions that I've set up. A over 2x plus 1, a equals 2. So the first fraction is 2 over 2x plus 1. Next we have the b fraction. b is 3, so we'll have plus 3 over x minus 2. And finally, the c fraction, c is -1, which will be minus 1 over quantity x minus 2 squared with respect to x. And now we're ready for step 2, apply integration rules. Our first term, 2 over 2x plus 1. Notice that we have a relationship of denominator is a function, numerator is the derivative of that function. The integral will be the natural log of the absolute value of the denominator, natural log of 2x plus 1. The next term works similarly. The denominator is x minus 2. The derivative of x minus 2 is 1. We have a 3 in the numerator, but we can take that out as a multiple. 3 times, and what would be left is 1 over x minus 2. X minus 2's derivative is 1, so this integral is 3 times the natural log of the absolute value of x minus 2. And going on to the third term, I'm going to rewrite the third term on the right side of the screen as minus x minus 2 is a quantity to the power of -2, which facilitates our integration. So we have minus quantity x minus 2 to the power of -2 will become quantity x minus 2 to the power of -1, and we will multiply by 1 over the new exponent, -1. I'll add my constant of integration, plus c. Now we've completed steps 2 and 3. Going on to step 4, simplify. For now, I will not change the first term. I have the natural log of the absolute value of 2x plus 1. The second term we can change to the natural log of the absolute value of x minus 2 to the power of 3, applying log rules. The third term, minus 1 divided by -1, is minus -1 or plus, and x minus 2 to the power of -1 is 1 over x minus 2 with our constant of integration plus c. And one more simplification. Notice that we're adding 2 log terms that are both natural log. They both have the same base. So we can multiply the 2 arguments and create one log expression, and we'll have the natural log of the absolute value of 2x plus 1 times x minus 2 to the power of 3 plus 1 over x minus 2 plus c. And this is the integral of the given expression. We've completed our requirements, and this concludes integration with partial fractions, example 1.